Hello, welcome to Astronautics for Exploit. This is Dr. Ayoshola Ogundele. Mars exploration, the past, the present, and the future, aimed at serving utilitarian purposes of knowledge increment and economic prosperity. The focus points are Mars exploration, the past, Mars exploration, the present, and Mars exploration, the future. The dream and desire to explore Mars, dated back to the 1950s, was championed by early rocket scientists and space exploration pioneers such as von Braun, Korolev, and many others. According to the research findings, Korolev in 1959 developed a four-stage Molniya planetary launch vehicle, which he derived from the two-stage R-7 ICBM that launched Sputnik in 1957. In 1960, he built a new planetary spacecraft for Mars and Venus. The successful launch of Mariner 4 on November 28, 1964, and the successful flyby of Mars on July 15, 1965, heralded beginning and a new era of Mars exploration. Mariner 4 took 22 pictures of the Martian surface from a distance of over 9,677 kilometers. Viking 1 and 2 launched on August 20, 1975 and September 9, 1975 respectively, monitored weather at their respective Mars landing sites, and reported on Martian temperatures, barometric pressure, and wind conditions. Viking data also determined that the planet's North Polar ice cap is made of water ice rather than frozen carbon dioxide, as had been previously thought. Mars Pathfinder launched on December 4, 1996 and landed on Mars Ares Fallis on July 4, 1997, determined the elementary composition of Mars rocks, and SWES provided images of the surrounding terrain for geological studies and documented the performance and operating environment for Pathfinder mission technologies. The Mars 2020 Perseverance rover mission addresses high-priority science goals for Mars exploration, including key questions about the potential for life on Mars. The 2001 Mars Odyssey mission is NASA's longest-lasting spacecraft at Mars, making the first global map of the amount and distribution of many chemical elements and minerals that make up the Martian surface. The ExoMars program is a pair of missions led by the European Space Agencies, which is designed to understand if life ever existed on Mars. The Mars Sample Return Campaign is an effort to bring samples of Martian rocks and soil safely back to Earth, where they can be investigated in unprecedented detail using all the capabilities of terrestrial laboratories. Mars exploration. Mars exploration is being carried out to investigate, by means of crewed and uncrewed spacecraft, the Mars for the possibility of the existence of life and its abundant natural resources. The information gained from Mars exploration will help to increase knowledge of the cosmos and benefit humanity. Image of a spacecraft near Mars is shown in this picture. Mars is one of the most explored bodies in the solar system and is the only planet where humans have sent rovers to roam the alien landscape. Various Mars missions and endeavors have found lots of evidence that Mars was much wetter and warmer with a thicker atmosphere billions of years ago. Illustration of a Mars pathfinder is shown in this picture. Mars is home to the largest volcano in the solar system, Olympus Mons. It's 3 times taller than Earth's Mount Everest. Mars findings. Based on past and present Mars missions, Mars appears to have had a watery past, with ancient river valley networks, deltas, and lake beds, as well as rocks and minerals on the surface that could only have formed in liquid water. Some features suggest that Mars experienced heat flows about 3.5 billion of years ago. Illustration of Viking lander is shown in this picture. Mars exploration, the past. Some of the past activities of the Mars exploration are Viking and landers, Mars Pathfinder, Mars Phoenix, Insight lander, Nozomi, and Mars 96. Viking landers. NASA's Viking missions to Mars was composed of two spacecraft, Viking 1, launched on August 20, 1975, and Viking 2, launched on September 9, 1975, each consisting of an orbiter and a lander, to obtain high-resolution images of the Martian surface, characterize the structure and composition of the atmosphere and surface, and search for evidence of life, are the mission's objectives of Viking lander. Volcanoes, lava plains, immense canyon, cratered areas, wind-formed features, and evidence of surface water are apparent in the orbital images. The picture here shows Viking spacecraft. Mars Pathfinder was launched on December 4, 1996 and landed on Mars Valles on July 4, 1997. It was designed as a technology demonstration of a new way to deliver an instrumental lander and the first ever robotic rover to the surface of the red planet. The mission achievements, both the lander and rover carried instruments for scientific observations and to provide engineering data on the new technologies being demonstrated. Pathfinder returned an unprecedented amount of data and outlived its primary design life. Pathfinder spacecraft in the Martian is shown in this picture. Mars Phoenix is another past Mars exploration endeavor. The goals of the Phoenix Mars lander were to study the history of water in the Martian Arctic, search for evidence of a habitable zone, and assess the biological potential of the ice-soil boundary. Phoenix studied the Martian soil with a chemistry lab, a microscope, a conductivity probe, and cameras. In August 2008, Phoenix completed its 3-month mission studying Martian ice, soil, and atmosphere. Illustration of Mars Phoenix is shown in this picture. InSight lander is another past mission of Mars exploration. InSight lander was the first outer space robotic explorer to study in depth the inner space of Mars, its crust, mantle, and core. InSight also measured tectonic activity and meteorite impacts on Mars. InSight was more than a Mars mission. It was a terrestrial planet explorer that addressed one of the most fundamental issues of planetary science. Understanding the processes that shape the rocky planets of the inner solar system, including Earth, more than 4 billion of years ago. Artist's concept of NASA's InSight lander is shown in this picture. Mars 96 is another past Mars exploration. Mars 96 was a failed Mars mission launched in 1996 to investigate Mars by the Russian Space Force. The Mars 96 spacecraft was based on the Phobos probes launched to Mars in 1988. They were of a new design at the time and both ultimately failed. Mars 96 was intended to improve humans' understanding of Mars. The scientific goal of the mission was to study the evolutionary history of the planet's surface, atmosphere, and inner structure. Other studies during cruise, such as astrophysical studies, were to be made. Mars 96 spacecraft at the assembly building is shown in this picture. Nozomi is another past Mars exploration. It was a Japanese Mars orbiter that failed to reach Mars due to electrical failure. It was constructed by the Institute of Space and Astronautical Science, University of Tokyo, and launched on July 4, 1998. Nozomi was designed to study the upper Martian atmosphere and its interaction with the solar wind, and to develop technologies for use in future planetary missions. Specifically, instruments on the spacecraft were to measure the structure, composition, and dynamics of the ionosphere. Artist's concept of Nozomi is shown in this picture. Mars exploration, the present. Some of the present activities of Mars exploration are Curiosity rover, 2001 Mars Odyssey, Mars Express, Marvin, Mars Hope. Curiosity rover was launched on November 26, 2011 and landed on Mars at 8:32 p.m. on August 5, 2012. Curiosity set out to answer the question, did Mars ever have the right environmental conditions to support small life forms called microbes? Early in its mission, Curiosity's scientific tools found chemical and mineral evidence of past habitable environments on Mars. It continues to explore the rock record from a time when Mars could have been home to microbial life. Illustration of Curiosity rover is shown in this picture. 2001 Mars Odyssey. The spacecraft was launched on April 7, 2001 and arrived at Mars on October 4, 2001. Its mission includes making the first global map of the amount and distribution of many chemical elements and minerals which make up the Martian surface. 2001 Mars Odyssey successfully completed its primary science mission from February 2002 through August 2004. The Orbital's extended operations continue today. 2001 Mars Odyssey is shown in this picture. Mars Express is another present Mars exploration. Mars Express is the ESA's first visit to another planet in the solar system. Since beginning science operations in 2004, the durable orbital has given scientists an entirely new view of Earth's intriguing neighbor and is helping to answer fundamental questions about its geology, atmosphere, surface environment, the history of water, and potential for life on Mars. Mars Express has been exploring the atmosphere and surface of Mars from polar orbit since arriving at the red planet in 2003. The picture here shows Mars Express. Mars Atmosphere and Volatile Evolution, MAVEN, was launched on November 18, 2013 and entered orbit around Mars on September 21, 2014. The mission's goal is to explore the planet's upper atmosphere, ionosphere, and interactions with the Sun and solar wind. Scientists use MAVEN data to explore the loss of volatile compounds such as carbon dioxide, nitrogen, and water from the Martian atmosphere to space. The picture here shows Mars Express. Mars Hope was launched on 19 July 2020. The space probe will study daily and seasonal weather cycles, weather events in the lower atmosphere such as dust storms, and how the weather varies in different regions of the planet. The mission achievements. Mars Hope will add to knowledge about Mars' atmospheric hydrogen and oxygen loss and other possible reasons behind the planet's drastic climate changes. An artist's impression of the Emirates Mars mission at the red planet is shown in this picture. Mars exploration in the future. Future activities of Mars exploration are Mars sample return, ExoMars rover and surface platform, and Starship. Mars sample return is an effort to bring samples of Martian rocks and soil safely back to the Earth, where they can be investigated in unprecedented detail using all the capabilities of the terrestrial laboratories. It is planned to be launched in 2027 and 28. The sample return mission architecture is designed to continue the work begun by NASA's Mars 2020 Perseverance rover. Mars sample return campaign artist concept is shown in this picture. ExoMars rover and surface platform is a pair of mission led by European Space Agency, which is designed to understand if life ever existed on Mars. The ExoMars rover mission currently includes providing critical elements to the premier astrobiology instrument on the rover. ExoMars rover picture is shown here. Starship. The Starship spacecraft and Super Heavy rocket, collectively referred to as Starship, are a reusable system designed to transport both crew and cargo to Earth orbit, the Moon, Mars, and beyond. A second Starship test flight advanced farther than the first, with the rocket reaching the edge of space but blowing up soon after. The picture here illustrates SpaceX Starship rocket. For more information, contact Astronautics for Exploit. You've been watching and listening to Mars Exploration the past, the present, and the future. Presented by Dr. Ayeshola Ogundele, with the focus points: Mars exploration of the past, Mars exploration of the present, and Mars exploration of the future. Thank you.